Hello, welcome to my Edexcel GCSE Statistics Higher paper. We're going to look at the June 2013 paper. First page has all the formulas on as usual. You should be very used to using these. Question 1. The two-way table shows information about the membership of a tennis club. We've got categories of a member as in adult, teenager or junior, and male or female. So if you are here, for example, that means you're female and a teenager, and the number shows you how many of those type of people we've got. In this case, we've got 10. Now the totals are speaking for themselves. If it's a total in the row, that means you add up the numbers in that row. So we'll do that straight away, and we'll get 43 add 31 is going to give us 74 in that section. You can always check that 74 add 22 is 96, add 24 gives you 120. Totals down this column, 43 add 12 is 55, plus another 10 is 65, and yet again you can check 65 add 55 is 120. Now you want to know what's missing here. If you want to add 31 to 10, you get 41. What else do you need to get to 55? Well, you need another 14. Job done. One of the club members is chosen at random. Write down the most likely type of member to be chosen. Now, we're not looking at the totals, we're looking at the types of members in the main section. So what is the highest number here? It's 43. So the type of member is male and adult. So we would write down adult male as our answer. Moving on, part 2. Find the probability that the member chosen is junior. Now, let's think about a probability. We say out of how many people we're talking, and that goes on the bottom of a fraction, and we say the ones that we're interested, that goes at the top. So we're talking about a total of 120 players. So we're picking from 120, so that goes on the bottom. And we now want to know how many juniors we have. So if we scroll up, we can see junior. We've got 10 male juniors, 14 female juniors, in total 24 juniors. So you could leave your answer as 24 over 120 if you like, but that simplifies if you divide by 24 to 1 over 5, aka 0.2. A teenage member is chosen at random to be on the club committee. Find the probability that this member is female. So they're teenagers that we're looking at. So we do not care about any of the rest of the table apart from those that are teenagers. So we've got 12 male teenagers, 10 female teenagers, 22 in total. Forget about everyone else, we're only picking it out of these 22. And how many are female? 10. So it's 10 out of 22 is your answer. That can simplify if you divide by 2 to 5 over 11, or if you like decimals, you can give your answer from your calculator as 0.45 to 2 decimal places. Okay. Question 2. The table shows some information about the total money spent in British supermarkets in the 12 weeks up to the 22nd of February for 2009 and 2010. It also shows the market share for each supermarket. So we've got the supermarkets listed in the first column, lots of different supermarkets. We've got 2009, remember we're only talking about 12 weeks leading up to the 22nd. We've got 2010, the 12 weeks again. Money spent and market share. money spent and market share. More money was spent in one of these supermarkets in 2009 than in 2010 for the 12 weeks in question. Write down the name of this supermarket. So basically, which supermarket did better in 2009? So which one had more money spent then? So we compare the 2009 money spent number with the 2010 money spent. Not Tesco, because this is higher. This is higher, not Asda. This is higher, this is higher, this is higher, this isn't higher, look. This is higher, 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 this is higher. Comparing with the previous one. So the answer is Summerfield. Summerfield. More money was spent in Netto in 2010 than in 2009 for the 12 weeks. Work out how much more money. So we go to the row with Netto and we look at 2009 and 2010, and we're going to do this number take away this number. So on your calculator, 161342 minus 159452. That gives you an answer of 1890. However, these values are in thousands already, so that means they need an extra 3 zeros on the end. Okay, so when we give our answer, you've got to be very careful to not just give 1890, but to make sure that that's times by 1000. So 1, 2, 3. And if you like writing numbers properly, you want to add a couple of commas in so we can see that that number is 1,890,000 to be precise. Moving on, part C. Work out the total market share percent for the first 4 supermarkets in the table for the 12 weeks in each year. So 2009 we're going to do first. Okay, so the first 4 supermarkets only and the total market share. So the first 4 supermarkets are the big 4 that you'll probably have heard of, and we want to add up these market shares for 2009. So simple case of using your calculator. I wouldn't risk making mistakes in my head. 30.1 plus 17.2 plus 16.2 plus 11.7. That gives you 75.2%. Your first answer. 75.2. And for 2010, it's the exact same technique. All we're going to do is we're going to add up the 2010 figures for the percent, of course. Here, 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 here. Okay, so 30.4 plus 17 plus 16.3 plus 12.3, and we're going to get 76% as our answer. 76%. Comment on your answer to part C. Well, what's the most obvious thing to say? It's that the percent market share has increased because the percent has gone up. Share for the top 4 supermarkets has increased between 2009 and 2010 for the 12 weeks in question. You don't have to go into that much detail, but just in case. There you go. Question 3. A new theatre was built in Appleyard. Appleyard Council wants to find out what people think of a new theatre. The council decides to collect information using a questionnaire. Keyword. State one advantage and one disadvantage of using a questionnaire rather than face-to-face interview. So first one, for the advantage, we want to say, why is a questionnaire better? Well, it's better because people can answer the question in their own time. And it's quicker and easier. Quicker, easier and cheaper than a face-to-face interview. Okay, so that's good reasons for it. Let's look at bad reasons, disadvantages. So we've got why, basically, would it have been better to do an interview? Okay. So basically we can say that in an interview, if the person being interviewed doesn't understand the question, then the interviewer can explain it because they're a real person. You cannot do that if it's a questionnaire. Whatever's written down is written down, and you can't do anything to change that. Okay. Another thing might have been that if you send out a questionnaire, people might not even bother answering every question or even giving it back. Okay. Moving on. Councillor Flowers wants this question in the questionnaire. Do you agree that the new theatre was a good use of council money? This is not a good question. Give 2 reasons why. Well, the fact that he's saying, do you agree, means that he's trying to tempt them to give a certain answer, to get them to agree, and he's giving his opinion. So it is biased because it's a leading question. It's trying to get the person being asked to give a certain answer. That's a leading question. Second reason is it's too open. Do you agree that the new theatre was a good use of council money? Someone could write an essay and say, well, yeah, in this case it is, in that case it isn't. Or someone could say yes, someone could say no. To stop getting endless answers in a question, what you want to do is give response boxes. So a reason why this isn't as good is it has no response boxes. There are your 2 reasons. Moving on. The council also wants to know how much people would pay to use the car park at the new theatre. Design a suitable question for the questionnaire. So let's try and make ours better and not fall for the trap that was wrong with the last question. So let's keep it nice and simple. How much would you pay to use the car park? Use the wording out of the actual question at the new theatre, and you need to tell them when. Are they going to get a pass for a week, just a one-off? So probably per visit is the simplest, so we don't confuse anyone. So let's give them some response boxes. Okay, and let's give some options. So obviously they might not want to pay anything, so it might be 0. And then you can't repeat 0, so let's start from 1p and go up to, I don't know, £3. And then let's go up from £3 1p, so we're not repeating. And let's go up to, say, £6, and then £6 to £10, or £6 1p to £10. And then the final one, we can't forget, we've got these tick boxes so far. What if they would have paid more than £10? They need an option 2. Okay, so final one, more than 10. Now we can say more than 10 because that doesn't include 10. And let's give a response box for the last option. There we go. So we've covered all bases and none of them repeat. Next part. The council decides to send a questionnaire to a sample of people. Give 2 advantages of taking a sample. Well, the first advantage is that it's quicker, easier, and cheaper than asking everybody or using the whole population. But the bad thing is, if you don't ask the whole population, you don't get everyone's opinion. Only the opinions of the people in the sample. Okay, so it's got some advantages and some disadvantages. Next part, the questionnaire is to be sent to 20 people chosen at random from a local telephone directory. So let's look back at what's going on. We're wanting to know a council of people in a local area, and it's in a place, Appleyard. Now I'd imagine there's a lot more than 20 people living in a town or even a village. So what you're going to say is that 20 is not enough people, is it? You need way more than that in a sample. Okay, so 20 people is not enough to be representative. And look at the way they've got the sample. They've got it from using the local telephone directory. These days, not everyone has their number in the telephone directory. Okay? Not everyone has their number in the directory, and not everyone has a house phone. So that's just not fair. Not everyone's got a chance of even being picked in the first place. Okay, 2 marks. We've given 2 reasons there. Question 4. A cycling club has a sponsored race to raise money for charity. The table shows information about the amounts of money the cyclists raised, and we're using X for the amount raised. And here we have the number of cyclists. We've used the word many times for a number of, called frequency. So you can add that word in yourself. That's the proper maths word. And you've got X and how many. So what we're going to do is we're just going to label these columns X and F. So X for our variable, the thing that's changing, in this case the amount of money, and F for how many, frequency. Sarah uses this table to calculate an estimate of the mean amount of money raised. Sarah's value for the estimate of the mean is an estimate. Explain why. Well, the reason is we don't know what the actual numbers are, and we've talked about this before. All we know is that between £20 and £30 raised, we have 3 people. For the exact mean, we would need to know the exact numbers. For instance, as a crazy example, 21, £22.50, and 29. That might be an example of what the 3 numbers could be. I could write down 3 different numbers. 27, 27 again, and £20.21. You see, I'm just making up three numbers and they all fit the bill that they are between 20 and 30. Unless we know what the original data is, we cannot figure it out. So that's our reason. Let's put it into words for 1 mark. For the exact mean, we would need the original data. Our data is in categories. So we do not know what the original data is or was. Okay, so that adequately explains it. A local cycle shop owner added £10 to the amount of money each cyclist raised. Okay, let's just shrink this for a second so we can see the question fully. Okay, so let's imagine they're raising money, and if before they raised £20.50, then what's going to happen to that £20.50? That is going to change to, instead of £20.50, £30.50. Okay? Every single number that you had is going to increase by £10 because the shop owner adds £10 to each one. Okay, each cyclist. So how is the mean amount of money raised? Well, every single number you add up is a tenner bigger, so your answer for the mean is going to be a tenner bigger. Okay, so it will increase by £10. And it's not yet asked us to find out what this mean is. Question 5. The table shows the simple index numbers for mean annual earnings in manufacturing for the years 2004 to 2006. The base year is 2000, year 2000. Okay, so the base year, which we will be referring back to, is the year 2000. So since then, we have had 2001, 2002, 2003 before we get to our table. Now the base year is started off as 100 or 100%, so when we compare we look at the change from the base year to here or wherever we're looking to. Describe the mean annual earnings in 2004 compared with the mean annual earnings in the year 2000. Now remember we said we started in 2000 with 100, 2004 it's gone to 112, so it's gone up by 12, can you see? Well, 12 what? It's gone up by 12 out of 100, and you should know if you go up, if you have a fraction over 100, it's the same as percent out of 100. So the answer is it has increased by 12%. And that's 2 marks. Okay, part B. The mean annual earnings in manufacturing for the year 2000 was 14,000. Work out the mean annual earnings in 2006. So let's go back to our table. So the index that we use, percent-wise, 100%, 112%, 116, 123%. But in terms of money, actual earnings, we're looking at 14,000 for the year 2000. And we want to know what's going to be going on in 2006. Well, our 100 went up to 123. Just like the question we just did, we want to add on 23%. But the way I like to think about it is we want 123%. Okay? Because we want 100 plus 23. So we want 123% of the money that we started with, which is 14,000. And you have your calculator, so we are going to use it now because I can show you a trick. If you're timesing by 100%, if you just want 100% of something, that's just the same as timesing by 1. Okay, because 1 keeps it the same, 100% is the whole thing. If you want to add stuff on, then you're going to increase 1, make it bigger. If you want to take away percent, you're going to make it small. If we want 123, well, this is 1.00, so this is times 1.23, and this is a very important thing called our multiplier. Okay, and that literally means that you can multiply the decimal by your number and you find 123% of it. If you wanted to find 107%, you'd times by 1.07. If you want to find 94%, you times by 0.94. We could go on forever. Okay, that's how it works. That's how good maths is. So on our calculator, let's do 14,000 times by 1.23. And we get 17,220. And that is your answer. Question 6. Jean is investigating if students at her college buy more e-books downloaded from the internet than books from shops. Write down a hypothesis, prediction, okay, that Jean could use. So she wants to know if they buy more e-books. So let's pretend that we're going to predict that they do buy more e-books. Okay, so students at Jean's college buy more e-book downloads than buy books from shops. Okay, so we made a prediction that we can test. That's called a hypothesis. Next part. There are 1,200 students in the college. Jean is going to use a simple random sample of 40 of these students. So you've got loads of students, 1,200, and you only want 40 in your sample. Describe how she could select the sample, include any possible problems. Well, a possible problem could be that you don't have a list of all the students. So let's write that down. Possible problem is she may not have a list of all the students in the college. Okay, but let's talk about if she did, if she was going to be able to do it. If she did, she could number the list of students from 1 to 1,200, then use a random number generator to select 40 random numbers from these. She should take the 40 students that correspond to these numbers, and that would make a sample. Okay, so to make a sample. Okay, so that's that done. Next question. The table shows the year and gender of the students in Jean's college. So male, female, first year students, second year students. Jean's tutor says gender and age may affect how likely a student is to buy ebooks. Jean now decides to allow for this in her sampling method. So it's basically saying that each of these groups might give different results, okay? And because there's more people in this group, say first year female students in the actual college, it would be unfair if we didn't have more of those in the sample, and it might affect our results. So basically we want a fair representative sample from each of the groups, and that's called stratified sample, when you have the same ratio in your sample as in the original population. So stratified sample, or sampling, is the method. Part 2, work out how many male second year students should be in Jean's sample of 40 students. So let's look at male and second year. Male second year, 240. Do you remember how many students were in the college? It was 1,200. So it's going to be out of 1,200, and we had 240 second year males. If you put that in your calculator, it will tell you the fraction simplifies to 1 over 5, or 0.2 as a decimal. That's basically just dividing top and bottom by 240. So that means that out of all the students, out of these guys, these guys, these guys, and these guys, we've got 1/5 going on here. So we want 1/5 in our sample, okay, of 40, because in our sample there's 40. So we're going to do 1 over 5 times by 40 to get 1/5 of 40, and that's going to give you an answer of 8. So that means in our sample we want 8 male second year students. Question 7. The multiple bar chart shows some information about the nutritional content of a standard chicken curry and a light chicken curry. And we have a key over here. Standard is in dark and light is in light. The information is given as a percent of recommended daily allowance, or RDA. Okay, so recommended daily allowance. So that means if your recommended daily allowance was, if what you ate was half of your recommendation of your daily allowance, then you could eat 2 lots of it in the day, otherwise you'd be going over. And you can see 90% up here is nearly up to what you should be eating in the whole day. And if that's just one meal, well, that's all you've got left for all the other meals and any other food that you eat in terms of saturates. Anyway, the missing information for fat is here. Fat, you can see there's no bars. Standard chicken curry is 54, light is 12. Complete the multiple bar chart. Okay, so we're going to draw on our rectangles, and we're going to fill the same way that they have. I just do a blue outline my rectangles. So the standard is going to be filled in black, and that's going up to 54. Let's just use the key that they've used. They've left 2 squares gap and then gone to the middle. So let's do the same thing and up to 54. You can figure out your key that it goes up 2 at a time. You can always just check at the side. And the next one is up to 12. This time we want our rectangle to have no fill, or fill it in white, and it's going up to 12. So just like that. Okay, so you've completed your bar chart just as it's asked, and that's 2 marks. Part B, write down the percent recommended daily allowance for salt in the standard chicken curry. So we go to salt, and we go to standard, which is from your key, remember, the one that's shaded in dark. And what you can do is you can just read off, and I'm in the mood for drawing a line, so let's get a dotted line so you can see where we're reading off, and it's going to be bang on 42. Okay, and it's already got the percent sign for you, so you just write 42. Part C. Write down the nutritional content with the lowest percent recommended daily allowance for a standard chicken curry. Okay. Looking up at the bar chart again, all we want is the lowest bar. That will give us the lowest percent, because percent's going up the side. We can see here that the sugar is the lowest, and it's between 10 and 12, so it's going to be 11%, but it wants the nutritional content, so you're just going to write the word sugar for 1 mark. Sugar. If you wanted to show off, you could put 11% as well, but there's no need. You would get the mark just for putting sugar. Next question, part D. Compare the recommended daily allowance for saturates in the 2 chicken curries. So looking back, let's look at saturates. That's the one that I've already commented on. There's 90% of your recommended daily allowance for standard chicken curry, and there is 28 for your light chicken curry. So let's just put that in words. We can see that a standard is way higher. I'll just make a note, 90 and 28. Okay. So the standard chicken curry has a lot more, or substantially more, or has a substantially higher percent recommended daily allowance than the light chicken curry. And you can give your numbers as well. So standard percent RDA was 90%. For saturates, and the light percent recommended daily allowance we said was 28% for saturates. Okay, so we've compared, we've said which one's higher, and we've also given the numbers to back up what we've said. Question 8. Time series graph shows information about the mean number of hours that people listen to the radio from 2007 to 2009. So we've got 2007 up to 2009, and each year is split into 4 quarters. Okay. Between which 2 successive quarters was the greatest change in the mean number of hours per week that people listen to radio? So what you need to do is think, okay, so going from one cross to another, when has it gone up or down the most? And when you find that point, that's your answer. So it's not going to be the first one that we've just highlighted. It could be the second one. It's not going to be the next one because it's not as big. That's not as big. That's not as big. Not as big. Not as big. No change. Not as big. Not as big. Not as big. So it's between the second and third quarter of 2007. Okay. So between quarter 2 and quarter 3 in 2007. A trend line has been drawn on the graph. We can see that. Describe the trend. Well, is it sloping up or is it sloping down as we go from left to right? It's definitely sloping down, so therefore it is negative trend, it is negative correlation. That's all we write for 1 mark. Negative correlation. C. Write down the value shown by the trend line for the median number of hours people listened to the radio in quarter 4, 2009. So we go to quarter 4 in 2009, which is here. We go up to the graph and we read off our trend line. This scale looks quite tricky to figure out, so let's think about how far up it's gone in that time. From 21.5 to 22, it's gone up by 0.5. And how many squares? 10 squares. So each one is divided by 10 to get 0.05 for each step up, aka 2 steps up. 2 of these is 2 times that, or 0.05 plus 0.05, which is 0.1, and we can see by counting up that this works. 21.5, 21.6, 21.7, 21.8, 21.9, and then 22. So the answer we're searching for is between 21.9 and 22. So that is going to be 21.95, and that's going to be your answer. 21.95 hours. Okay. Part D. Comment on whether your answer to part C is likely to be higher or lower than the true value, and give a reason for your answer. Right, well, let's think about the estimate that we've just made. We've just been guessing where the next cross is going to be, and we've guessed that the next cross is going to be here. But if we have a look at what's happened with our points, it's gone down, 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 across. Okay, that's 4. Up, down, down, cross. Up, down, down, maybe across. Okay, we're trying to follow the pattern from quarter 1 to quarter 4. So quarter 4 doesn't drop down as much as the others. Can you see that here it's a little drop, here it's hardly any drop, and here we'd probably expect between a drop like this and a drop like that. So we expect the real value to be higher than the trend line suggests in part C, because there is usually little decrease between quarter 3 and quarter 4, so it would not be brought below the trend line. Okay, bit of a dodgy question, but there you go, that's your answer. Question 9. 100 planes landed at Heathrow Airport in a 3-hour period. 40 of the planes were from Europe. Okay, planes from Europe, we've got a circle over here. So if I highlight the planes from Europe, anything within this yellow highlighted region is from Europe. Okay, 20 of the planes were late, including 5 planes from Europe. So the circle next to the yellow one is late planes. So if it's in the middle of both, then it was from Europe and it was late, and we've just said that 5 planes were late from Europe, so 5 goes there. That means to make up to 20 in total in this late plane circle, we need another 15 here. And planes from Europe, we want 40 in total in the yellow area, so we need another 35. And we want all our planes to add up to 100. Now the problem is, so far we only add up to 55 with the late planes and the planes from Europe. Well, guess what? That's why we have a box around our Venn diagram, around our circles, for anything else or other. So other is going to be not late and not from Europe, and it's going to be what you need to get from 55 to 100, which of course is 45. If you're not sure, you can use your calculator on that one. Okay, so we're going to put this 45 anywhere in the outside area. And that's your answer for 3 marks. One of these planes is chosen at random. Find the probability that I, the plane, was not from Europe. Well, there's 40 planes from Europe, so that means that there's 60 that aren't from Europe. And we're talking about 100 planes in total, so it's 60 planes out of 100, and that's your answer. 60 out of 100, and that simplifies to 3 over 5 or 0.6, however you want to give your answer, and your calculator will help you to do that. Part 2. The plane was on time and was from Europe. So if this is the late guys, then the other ones, if they're not late, they're either on time or early. But let's say on time, because that's how the question's been set up. So there are 35 out of the total number of planes, which was 100, and you can leave that as your answer if you want, or you can simplify the fraction by dividing by 5, or you can put it in your calculator or convert to decimal 0.35. Next one, given that the plane was late. So this is very important, and we're going to go straight to the diagram, and we're going to zoom in, and we're only going to look at the area where the plane was late, because given that means you know for sure that it was late. So you're not interested in the 35 number, you're not interested in the 45 number, only these two numbers where the plane was late. Okay, so add them together, there's 20 planes that were late, so our probability is going to be out of 20. So given that it was late, what's the probability it was from Europe? So remember, ignoring the others, we don't care about those anymore, they're not late planes. How many were from Europe? It's this 5, because they're also in the Europe circle. So it's 5 out of the total number in green, which is 15, add 5, so 5 out of 20. That can be written as 1 over 4 or 0.25 for 2 marks. Okay. Question 10. The box plot shows information about the heights of a sample of skyscrapers in Asia in 2010. So we can see that here. And remember, a cross stands for an outlier that doesn't fit with the original data. Write down the median height. Well, the median in the box plot is the one in the middle of your box. So it's read off here, and we need to figure out the scale. Halfway between 200 and 300 is 250, and we need to think, well, 200, 210, 220, 230, 240. It's going up in tens. 250, 260, 270, 280. That is 290. And the height is in meters, which is already done for you. Part B, work out the interquartile range. So that means your upper quartile, which is here, which is between 300 and 400, bang in the middle, 350, and between the lower quartile, which is here, which is 260. So between 350 and 260, the answer, you can do 350 minus 260 and you get 90. You can do it on your calculator if you're not sure. Okay, so that's the interquartile range. What does a cross on the box plot mean? Okay, so this is an outlier. That does not seem to fit with the rest of the data. Okay. Next part, the table shows information about heights of a sample of skyscrapers in America in 2010. So let me guess, we're going to have to draw it onto a diagram. The second tallest skyscraper in the sample is a height of 350 meters. Show there is only one outlier for these data. Okay. So let's look at the data again. I've pasted in the data from the previous page, and we know if we've got our number line that the maximum that we've got is 442. You might think, why is it telling me about the second tallest? Do I really care? Well, yes, because if this is the tallest, you know that the very next number coming after 442 is 350, the next biggest one. Then you've got the upper quartile, which you know about. You've got the median that you know about. You've got the lower quartile that you know about. And you've got the minimum that you know about. Okay, now we don't know about values in between here, but we do know that there isn't any more there until you get to 442. That's very important. So show that there is only one outlier for these data. Well, what we do to find an outlier is we think about the interquartile range, which is the upper quarter, take away the lower quarter, so that gives you 45, and we do that times 1.5, so you can check on your calculator, 45 times 1.5, and that's going to give you 67.5. Now we add that onto the upper quarter, so 300 plus 67.5 gives us 367.5, and for the upper outliers, for the lower outliers, we're going to take away that 67.5 number from our lower quartile, so 255 minus 67.5, going to use a calculator, 187.5. So we know from our number line, if we have anything that's less than 187.5, then we've got an outlier. If we've got anything bigger than 367.5, then we've got an outlier. So we just need to explain that no lower outliers and only one higher outlier. So no lower outlier and 442 is the only outlier above 367.5, which was the value that we worked out for the cutoff point. Okay. Part C. On the grid opposite, draw a box plot for the heights of the skyscrapers in America. So let's take this table back again and let's draw the box plot. Okay, so we want the minimum, which is going to be at 240. We've already labelled some stuff on, but we know that 240 is here. And let's make it very similar to the last one. So 240 minimum, maximum 442, so 400, that's 450, that's 440, so 0.2 is just a little bit into this there. Done. Upper quartile 300. We're going to do a box a little bit bigger, just copying from below. 300, 270 is going to be this value here. You'd be using a ruler. Lower quartile 255, which is between 250 and 260, which is just here. And we finished off our box plot, just joining the lines. Okay, now I've made an intentional mistake there because that does not show the outlier like the other one. If we drew it without the outliers, that would be our answer. But let's just get rid of this because we figured out that 2442 was an outlier. So instead of putting the line there, what we're going to do is put a cross instead to show that it's an outlier. And the rest of our box plot is only going to go up to the second highest value. And can you remember what the second highest value was? It was 350. So we're going to take this back to 300, not the cross. We're going to take the end of our box plot back to 350. And we're going to just finish off our diagram properly now. Okay, quite a stubby box plot. Done. Compare the distributions shown by the box plots and state which has the tallest skyscraper, Asia or America. So, assuming that the outliers are correct piece of data, the tallest one is in Asia. Okay? Because this is over 800 and there's none anywhere near that in America. So let's write that straight away. Okay. The tallest skyscraper is in Asia. And let's also compare distributions as we would normally. And remember what I always say, look at how many marks. 4 marks, 4 points. We've already made 1 point, so we need at least 3 points here. We can say the median is bigger for Asia, because we can see here that this value is bigger than this value. So let's write that in. The median is bigger for Asia than America. Another point, we could say the interquartile range is also bigger for Asia, which we've said is 90 here, and it's much smaller for America. Okay, so the interquartile range is also bigger for Asia than for America. And let's look at some skewness. The third thing we're going to look at, the trick that I've been trying to tell you in these videos that I really like is about drawing a P. And it's quite hard to show you on the video what I mean by that, because I quite often draw my P's a bit dodgy. So if you imagine your P is like that with a long stalk, and you turn it around, now any P that you draw, you can imagine as a box. Okay, it's P for positive, and you can imagine, well, there's the start of my box, there's a line, there's that line, join them up, and you've got something that represents an actual box plot for you. Okay, so we can think, is it similar? Is it similar? Yes. these actually both have little p's that you can draw, one here and one here. Okay, so both positive. If your box plot was like this, I'm sorry, but for this purpose, you haven't got a P. What you've actually got is a B. If you turn it around, it's either going to be a back to front P, which you don't want to draw, or a B. Okay, so that's just meant to be a quick way to remember that this is negative, this means positive. Okay, so both Asia and America have positive skew, or both distributions have positive skew. That's 4 comments that we've made, so that will get us 4 marks. Okay. Question 11. The total rainfall and total hours of sunshine were recorded in August in Whitby over an 11-year period. These data are shown in the scatter diagram below. So we've got total rainfall at the side and hours of sunshine across the bottom. The line of best fit is drawn on the scatter diagram. In August of next year, there were 200 hours of sunshine. Find an estimate for total rainfall. Each cross in this scatter graph represents one of the years. Now we're not labelled, so we don't know which is which, but there should be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for the last 11 years. We're not bothered about which year they are. All we're bothered about is how the number of hours of sunshine affects the total rainfall. And the one in question for us is when there is 200 hours of sunshine. So it just so happens really that it's next year. So we go to 200 hours, we go up, and then we go across, and we're going to get to, we need to check our scale out here. It looks like to me it's going up in 4s, but let's check it out. Okay, so if it goes to the middle, that's 50. So 40, and then it goes up 44, 48, and then half. So 44, 48, 52 is where we're at. So that is our answer for the estimated rainfall in millimeters. Okay, it's already got millimeters for us. Describe the correlation between rainfall and number of hours of sunshine. Reading from left to right, our line is sloping downwards, so it's negative correlation. This gets asked in just about every paper. Describe the correlation. Negative correlation. Calculate the gradient of the line of best fit. Now the gradient is the change in y over the change in x. Okay. Now in maths sometimes we can use a triangle to mean change. Mathematicians do not like writing too much, and that is a Greek letter called delta, capital delta. So the change in y over the change in x. Now what I mean by change in y is how it changes up or down, and in x, left or right. Now up is positive and right is positive, and if you go backwards it's a negative. So let's check out our gradient. Let's be as accurate as we can be here, and what we're going to do is use a nice straight line ruler, and we are going to use a dotted line to try and figure out a change in y vertical and a change in x horizontal. Now you do that by drawing a triangle onto your diagram. You can draw the triangle anywhere, but probably go for lines that make it quite easy. Can you see that I've followed the lines on the graph where I can see that the black line, the trend line, is going to be crossing the axis at a nice point. So let me show you what I mean by that now. If we go across from our value here, it's bang in the middle of the two lines, we can go across here, and that's 40. We can go down here, that's 140, and we can go down here, that is 212, because we can see that we go along by 2 each time on the horizontal scale. And if you're not sure, you can have a little check of that yourself by just checking along. Well, in the middle, 210, 12, 14, 16, 18, 20. Yep, it works. So this value here is at 212. This value here is at 140. So to get the change in x, you're going to do 212 take away 140, which gives you 72. And it's a positive change because it's going the right direction. Here we're going from 40 to, well, we said before, we figured out the scale was going up in 4, so 104, 108, 112, 113. So 113 minus 40 means that the change here is 73. Now, because it's going down, we need a negative sign. So change in y, horizontal, over change in x is minus 73 over 72. And if we do that on our calculator, we're going to get a decimal of 1.0138, or 1.01 to 2 decimal places. That 8 would have been reoccurring. 1.01 to 2 decimal places. Part 2. Interpret the value of this gradient. Okay, so it means if we step, negative, if we step across 1, okay, it's very important that if we have a change in x as 1, on the top minus 0.101. So for every one we go across, we go down 1.01. Let's see what across and down stand for. Across is hours of sunshine, and down is to do with the total rainfall in millimeters. Okay, so let's try and use our units as well. If the number of hours of sunshine increases by 1 hour, then the amount of rainfall, because it's a negative going down, will decrease by 1.02 millimeters. Okay, and that's interpreted, which means we've related it to the actual question of what's going on with the rainfall and the hours of sunshine. Remember, hours of sunshine going across, rainfall going down, negative correlation. Okay. There are 8 dancers in a dancing competition. Judge X and Y each put the 8 dancers in rank order. Rank 1 is for the best dancer. Okay, so these are the dancers A through to H. Work out Spearman's rank correlation coefficient for these ranks. You may use the blank columns in the table to help with your calculations. Good, because we're going to need the blank columns. We've already got the values ranked for us, so that's a good start for us. But what we need to do now is find D, which is the difference between the ranks. So we can call for rank of judge X, XR, and the rank of judge Y, YR. So effectively we're doing this column minus this column. 2 minus 4 minus 2, 5 minus 2, 3, 1 minus 5 minus 4, 4 minus 1, 3, 6 minus 8 minus 2, 7 minus 7 is 0. 8 minus 3 is 5. 3 minus 6 is negative 3. Now, because we're not too concerned with the negatives, we want to measure how different they are without them cancelling out. We square these numbers. When we square, I've talked about this in other videos, we do not have to worry about a negative because minus 2 times minus 2 is the same as just 2 times 2, which is 4, by the way. 3 squared is 9, 4 squared is 16, 3 squared is 9, 2 squared is 4, 0 squared is 0, 5 squared 25, 3 squared is 9. Now we go and we think about our formula page, which tells you that the Spearman rank correlation coefficient is equal to 1 minus the sum 6 times the sum of d squared, 1 minus 6 times the sum of d squared over n times n squared minus 1. You might learn it after you've done it for a while. I know I have, without even meaning to really. Now the sum of d squared just means that you add up this column. So on your calculator, let's go for it. 4 add 9, add 16, add 9, add 4, add 0, which you don't need to do, add 25, add 9, 76. And we're going to be doing 6 times that in a second. N is how many you've got. So 1, 2, 3, 4, 5, 6, 7, 8. N is 8. We have 8 answers. Okay, so now in our formula we're going to do 1 minus 6 times 76 this time, because we know what the sum of d squared is, divided by n, which is your number 8, times by, getting quite annoying changing colour every time, 8 squared minus 1, and we're going to scroll down to give ourselves a little bit of space, but we can just put this into our calculator. 1 minus 6 times 76 on the top of a fraction, 8 times brackets 8 squared minus 1, and that's going to give us an answer of 0.095238, which is 0.095 to 3 decimal places, which is actually very close to 0. Interpret your answer to part A. I've just said that it's close to 0, and our Spearman rank only goes between -1, negative correlation, 1, positive, 0, no. We're near 0, 0.0. If we were rounding to the nearest whole number, then we would actually be on 0, because the 0 would just keep it the same. That's another story. Hopefully you can see that is actually very, very close to 0. So there is no correlation, i.e. there is no relationship between how the two judges ranked the dancers. Question 13. Some students did 2 mathematics tests. The students' marks for the tests were normally distributed. The diagram shows the distribution of the marks for test 1 and for test 2. Estimate the mean and standard deviation for the marks for test 1. So what you need to know about the normal distribution is that it's called a bell-shaped curve, which are the shape of these. If you basically imagine a 3D bell, that's where the name comes from. Imagine ringing that bell thing in the middle. Okay, well, we're talking about this part of the bell, so that is the normal distribution shape. Now, if you imagine that these are all how many bits of data you've collected, this highest one is where you've collected the most data, where you've got the most data. So that is actually the mean. What else do I have to estimate? The standard deviation. Now, basically, if you cut it in half, because it should be symmetrical, you can take 3 standard deviations before you get to about the end of your data, pretty much. Okay, and it's just an estimate, so that will be fine. So let's go for test 1, down the middle. It's just an estimate, so we don't have to be perfect. And it looks like bang on between 50 and 60, maybe a little bit less. So anywhere between 54 and 55 should be fine. I'm going to go with 55 because I reckon, looking at here, it is about halfway between. So mean is 55. And what we have to look at as well is splitting it up into 3. So from 55, if we go to 85, then that is a gap of 30. Remember I said we were going to split this gap up into 3? 1, 2, 3. Okay, 65, 75. 1, 2, 3. So we've split up our data, and that means that the standard deviation is this gap here, which is 10. Okay, SD for short, 10. They're only estimates, okay, but those numbers are quite nice, so you should be pretty pleased that you've probably got that right. Moving on. For test 2, the median mark is 64, the standard deviation is 12. One student got 60 marks on both test 1 and test 2. Find the student's standardized scores and compare how well the student did on the 2 tests. Okay, so standardized score, what you have to do is you have to take your mark, which we'll call X, subtract the mean, and divide by the standard deviation, SD. So, we got 60 on both. So for test 1, it's going to be 60, take away the mean, and can you remember what we got for the mean? 55, divided by a standard deviation, which is 10, and you might be able to do that in your head. 0.5 is the standardized score. For test 2, we've got the same mark, 60 again, but we're going to take away the mean of 64, divide by a standard deviation of 12, so that's going to give us minus 4 over 12, which is minus a third, which is minus 0.33 to 2 decimal places. So let's read the question again. Find the student's standardized score, compare how well the student did on the 2 tests. So let's write a bit about that. A positive score says that you've done better than average. Negative score says you've done worse than average. So in test 2 he's done worse than average. Test 1 he's done better than average. Okay, so he has done better in comparison on test 1 than on test 2. Because the standardized score is higher on test 1. Cool. Okay, anything else? 5 marks for that, because there's a fair bit of work to get your 2 values and then to write the little comparison. Next one, question 14. The table gives some information about house prices in a small town where we are using P in thousands of pounds to represent the house price. The number of houses, aka the frequency, is shown here. So there's only one house where the price was between 100,000 and 200,000. Okay. Some of these data are represented on a histogram. So let's have a look at our histogram below. We've got 3 bars so far. Use the table to complete the histogram. Right. So for a histogram, we need width and we need the frequency density, which is basically the height. Okay. So to get the width, how wide it is, well, think if it's going from 100 to 200, 100 wide, 100 wide, 50 wide, 50, 100, 200. So we know how wide they are. Now we're thinking about, this is frequency, how many, and I told you before that the rectangle for each bar has frequency as the area, has the class width for the horizontal, and the frequency density for the vertical. So we have to find the frequency density by figuring out what multiplies by that to get that. Okay, let's move this column across if we can. So because we know that the frequency density will be timesing with W, the class width, to get the frequency, we can rearrange this and say, well, if you divide the frequency by how wide it is, you'll get the frequency density. So you can get a couple of formulas out of this. So that is exactly what we are going to do. We're going to divide each one. Okay, and some you can do in your head. Like 1 divided by 100, 0.01. 9 divided by 100, 0.09. Divided by 50, well, you could divide by 100 times by 2, 0.2. But I wouldn't recommend this probably in an exam. So let's do it on a calculator. 8 divided by 50 is going to be 0.16. 2 divided by 100, 0.02. 3 divided by 200 is going to be 0.015. Okay, and now we're ready to plot our values on. So we've already got up to 350. So we're already done up to here, and let's just check that goes to 0.2. Sure does. First thing that we need to do is think about scale. So if we're going from 0 to 0.05, we've done that in 10 or 5 big steps. So each big step is 0.01. Okay, so we are going to go for our first one. We're going to go between 350 and 400 and up to 0.16. Now we've just figured out the scale. So it's going to be 1, 5 and then an extra double step. Done. Let's change the colour, why not, make it nice and pretty. Okay, next one we're going to do from 400 to 500. It's going to only go up to 0.02, not far at all. So that's 0.1. Sorry, 0.01, and that's 0.02. And the final one, let's change colour again. This one is going to go from 500 to 700 and go up only 0.015. So 500 to 700, that's 0.01. That would be 0.02, so halfway between 0.015. That is the histogram complete for 3 marks. Jason thinks a median of these prices is 350,000. Jason is wrong. Explain why. So let's look back at the graph and see where 350,000 is. And we're talking about the middle number. So is the median 350,000? So we'd just say 350 for using this table, aka here. Now, how many numbers are there? 1 plus 9, 10, 20, 28, 30, 33. The middle of 33 numbers is going to be the 17th number. Okay, or you could say 16.5, but we're going to go 17. If you imagine you cross them all out, that's what you get to. So let's count up. By the time we get to £200,000 price barrier, we've had one house. By the time we get to 300, we've had 10 houses. 1 add 9. By the time we get to 350, we've had 20 houses. Okay, so it is between 300 and 350. And it's the main thing to remember is this sign that says less than 350. So that's what we're going to say. The median is between 300 and 350, not including 350. The median is between 300 and it's 1,000 and 350,000, but not including 350,000, since it is just less than 350,000 and not less than or equal to. And this is from the table. Okay, so yeah, I've explained why Jason is wrong. So Jason is wrong, let's just rub it in. Okay. The mean price of these houses is 340,000. Find an estimate for the number of these houses with a price less than the mean. So thinking about 340,000, let's go back to our histogram and let's go to 350,000 and let's put a line. Okay, so 350,000, 340,000, let's put a line straight up. So that is our median at 340,000. Okay, so we want to know how many are less than that, I believe. Yep, so what we want to do is work out how many values are here, here, and here. Now remember that we said area of a histogram represents how many are there. Okay, so if we want the area of this one, well, we can just think about from the table that means one house. Okay, so that's 1. Second one, let's look back at the table to see what that one represents, and that represents 9 houses. You could do it a slightly different way, which is thinking, well, it goes up to 0.9, sorry, and it's times by 100, and if you do that on your calculator, lo and behold, you get 9. Now this whole area, the whole bar together, would have been 10. Now we haven't got the whole bar, so we need to think very carefully about what we actually have. So you now have drawn one line down. I've actually got 1/5 of it there, because look, 1 strip, 2 strips, 3, 4, 5 strips. So if we want this side, we actually want 4/5 of it. So times by 4 over 5, which is going to give you 8. And you could see that as a fraction is 8 out of 10 times it by 10, you just get the top 8. So we've got 8 plus 1 plus 9. 8 plus 1 plus 9 is going to give you 18. So that would be your answer. Okay, 18. Moving on to question 15. A production line is set up to produce chocolate bars with a target weight of 104 grams. For quality control, random samples must be taken to check the production line is working correctly. The chocolate bars in each sample should have a mean weight of 104 and a standard deviation of 2. The sample mean weights have a normal distribution. Remember what we talked about a few questions ago? The bell shape. A quality control chart is used to plot the sample mean weights. The lower warning limit and the lower action limit, shown here, have been drawn on the chart. Complete the control chart by adding the upper warning limit and the upper action limit. Okay, so looking at the graph and the information, we know that because it's a normal distribution, this is symmetrical. So it's going to be the same going across, up past the target weight as it is below. And because when we go down, we've gone down from 104 to 100, when we go up, we're going to go up the same distance, so we're effectively going to add on 4. And that is going to be our upper warning limit, and the same kind of thing for our action limits. Because it's symmetrical, this distance here will be the same for the upper limit, so we're going to have our line across there too. And let's just write on to label what they are. So the first one is the upper action limit, not bother writing limit, and upper warning, because I couldn't fit it on, that's all. Oh, I'll tell you what, let's shrink the text size. Action limit and upper warning limit. Okay, so we complete the table, we've added on the 2 lines and we've labelled them. Part B. When the chocolate production line is working correctly, write down the percentage of samples expected to have a mean weight outside the warning limits. Right, so you need to know about your normal distribution here. So because we've got a standard deviation of 2, as shown in the question, remember I said to you before that most of your data is 3 times the standard deviation away. Now look, if we go 1 standard deviation above, we're on 1/6, 2, 3 above, and that is 3 above. Like I'm saying, these should contain most of your data. Now it's not just good enough to say most of your data sometimes, it actually contains 95% of your data. So that means if all of this area is 95% of your data, all of this, then what's left over is just 5%, because obviously you have 100% in total. So this is a bit of an applied question of a bit of theory that you might have learned. 5% is left over there. Next part. 5 sample means have been plotted on the control chart. The next sample has a mean weight of 97.8 grams. Plot this sample mean on the control chart. Describe the action that now needs to be taken. Okay, 97.8, let's go back. So we're at the 6th one because we've already done 1st, 2nd, 3rd, 4th, 5th, 6th, and we're going to plot it at 97.8, which is going to be below 100, below 99, there's 97, and we're going up in 2, 4, 6, 8. Yep. So each little square is 4 here, so the scale is very, very tricky. So anyway, that's 97, 0.2, 0.4, 0.6, 0.7, 8, just up there. Okay, there's a cross, and then only leave one cross on, so we get rid of that. Describe what action needs to be taken. Well, what happens when we're below the lower limit? Well, we are outside our take action part, so we take action and we can stop the production process and see what's going on. Part D. Explain how warning limits on a control chart are used. Well, a warning is just that, it's a warning. So if one sample is outside the warning limit but inside the action limit, you must test another sample. So what we're saying is, okay, well that looks a bit dodgy. We'll test another one, see how that one looks. Okay, and if next sample is outside the warning limit, then stop the production process. But if it returns back to normal, then you can let things carry on because it's just a warning. But if the next sample is not outside the warning limit, then allow the process to carry on. Okay, quite a wordy question, quite a lot of wordy questions on these statistics exams, just shown by how often I have to use the text tool. But we are done on this paper now, 100 marks. Hope it's been useful. Hope your revision's going well and that ultimately you are going to achieve maths. Thank you.